Welcome to the Explainer. So if you're building any kind of software today, you are almost certainly working with distributed systems. And in that world, you have to accept one hard truth. Failure isn't just a possibility, it is an absolute inevitability. So the real question is, how do you build apps that don't just survive the chaos, but actually thrive in it? Well, let's get into it. It always starts with something simple. So simple you barely even think about it. Just a single request from your application to some other dependency. Maybe it's an API, maybe a database, and at first glance, everything looks perfectly fine. But then, you get that first little hint of trouble. That downstream service, it starts to lag. Now, it could be anything, right? A network hiccup, maybe it's temporarily overloaded, just a classic transient fault. Now, your application, trying to be a good citizen, does exactly what you told it to do. It retries. It tries once, then tries again, maybe with a nice exponential backoff. It's just doing its job, trying to get a successful response. And this right here is where things get really dangerous. See, while that very first request is still stuck in its own retry loop, brand new requests are coming in from users, they fail too. And guess what? They also start retrying. All of a sudden, what was a tiny trickle of failures has turned into a self-inflicted flood. There's a name for this, and it's absolutely terrifying. Load amplification. Your system's own well-intentioned recovery plan, all those retries, is now basically launching a denial of service attack against its own dependency. You're trying to fix the problem, but you're actually making it 1,000 times worse. Well, this often leads to something called a meta-stable failure. And that's a really fancy way of saying the system gets so overwhelmed by its own attempts to recover that it can never get back to a normal state. A single, tiny fault has now cascaded, bringing your entire application to its knees. So how in the world do we fight back against this kind of inevitable chaos? How do we build systems that don't just fall over, but adapt gracefully? Okay, let's dive into the core patterns that form our defenses. We have to build for resilience. It starts with accepting that failures are just a fact of life in distributed systems, and we have to proactively engineer our applications to handle them. Resilience isn't some luxury feature, it is an absolute necessity. So let's look at the essential building blocks for a truly robust application. Now, there are several key resilience patterns, but for now, we're going to zero in on two of the most fundamental ones, the good old retry and the circuit breaker. The retry pattern is pretty much our first line of defense. It's absolutely perfect for those temporary, transient faults that are probably going to disappear on their own if you just wait a second. But as we just saw, if you're not careful, uncontrolled retries can become a weapon of mass destruction. So what happens if the service isn't just a little slow, but it's completely down? Well, hitting it with more and more retries is just pointless. It's like knocking on a door when no one's home. And that is where the circuit breaker pattern comes in. It is designed to fail fast, and in doing so, protect your entire system. A circuit breaker has 3 states, and it's pretty intuitive. It starts out closed, which is normal operation. Requests are flowing just fine. But if failures start piling up and cross a certain threshold, the circuit trips and moves to open. Now, it immediately blocks all new requests, which is crucial because it gives that downstream service time to recover. Then, after a set cooldown period, it enters a half-open state. Here, it lets just a single probe request through. If that one succeeds, great, the circuit closes and things go back to normal. If it fails, it stays open. It really is just like an automated electrical breaker in your house, but for your code. Okay, so that's the theory, but how do we actually put this into practice? Well, for .NET developers, the answer is pretty clear. When you say resilience, you're really talking about one thing, Poly. It is the de facto standard for implementing all these patterns. And with the release of version 8, Poly got a massive architectural overhaul. The old kind of clunky policy wrap is gone. It's been replaced by this modern, super high-performance resilience pipeline builder. This thing gives you a really clean, fluent API that's not only way simpler to use, but it also has significantly lower memory allocation. And that means it's much, much faster on those performance-critical hot paths. But hang on a second. There's a really critical detail about retries that we've kind of glossed over. What happens when the operation you're retrying isn't actually safe to repeat? Just imagine this scenario. A network timeout happens right after a payment request is processed on the server. Your client never gets the success response back, so it does what you told it to do. It retries. You've just charged the customer twice for the exact same thing. This isn't just a bug, it's a catastrophic failure of a completely different kind. The solution here is a really fundamental concept in API design called independency. And the best analogy is a light switch. You can flip it to on as many times as you want, but the light just stays on. An independent operation is the same. You can repeat it safely over and over, and it won't change the outcome beyond that very first call. If you think about HTTP methods, get, put, and delete are all naturally idempotent. But the problem child here is post. Why? Because by default, every single post call creates a brand new resource. And that's exactly where our double-charged disaster scenario comes from. So how do we fix this? We use something called the idempotency key pattern. Just think of it like a secret handshake between the client and the server. The client generates a totally unique key for the request. The server gets it and first checks, hey, have I seen this key before? If it has, it doesn't reprocess anything. It just returns the original cached response. If the key is new, then it processes the request and saves the result along with the key. It's an elegant solution that guarantees the operation is performed exactly once. Okay, so we've designed this awesome, resilient system. We've got our circuit breakers, we've got our safe retries, but how do we actually prove that it works? Do we just wait for a real production outage to find out if we got it right? No way! Instead, we embrace chaos engineering. This is the discipline of proactively and intentionally injecting failure into our own systems. We do it to find the weak points before our users do. And the absolutely brilliant thing is, Poly V8 has chaos engineering capabilities built right in. You can now add what are called chaos strategies, like injecting random faults or adding artificial latency directly into your resilience pipeline. This lets you continuously test that your application behaves exactly like you expect it to, even when things are going haywire. All right, for our final thought, let's zoom out a bit. We've been talking about building resilience right inside your application code, but there's another place where these concerns can live, in the infrastructure itself. And this brings us to the world of the service mesh. Tools like Istio and Linkerd, they operate at the infrastructure level. They basically act as a smart proxy between all your services, and they handle things like retries and circuit breaking for you automatically without you needing to write a single line of application code for it. So this presents a really key architectural choice. Do you want that fine-grained control inside your code, or do you prefer to offload resilience to the platform? The trade-off often comes down to Istio's deep, powerful, but complex control versus Linkerd's intense focus on simplicity and raw performance. So here's the key takeaway. Whether you build resilience into your application code with a library like Poly, or you handle it at the infrastructure level with a service mesh, it is no longer optional. It is the absolute foundation of any modern, reliable piece of software. And that leaves just one question. How resilient is your application?
Before you head out, let me leave you with a small ask. If this video made your .NET brain spark even a little, hit that like button. It takes you 1 second.